Hello, Kevin Carey with Powertron Global. In our third and last segment, we're going to talk about our forensic data. We're very proud of it, and you are going to love it. Many clients in the field ask us to use their traditional control systems to analyze our technologies and our services, everything that we provide. The problem with those is that most control systems don't collect data at a high enough sample rate. They don't allow us to manipulate the software so we can analyze data in ways to let us diagnose and find the inefficiency. And they don't give us the flexibility we need when we're digging. They're not forensic systems. So we had to develop our own. We collect a lot of data across an entire spectrum of temperatures and diverse conditions. We're effectively conducting an AHRI standards test every second that we're monitoring. The data's great, and let's take a look at it. What's significant about our forensic testing is that it's absent of modeling. Models have their problems, and we don't want to use modeling when we have the ability to use accuracy. That's a big difference in what we're trying to do with this level of testing. In the field, it's very hard to contain variables, so engineers, professional engineers in particular, typically want to see 500 to 1,000 points of data, comparative points, so that they can let the numbers be the numbers, and they can do their best to mitigate any variable interference in the final results. When we use forensic testing in the way that we measure and at the rate that we measure, we're going to generate tens of thousands of those same points that they're looking for. So the confidence of data is extremely high. It's also much more accurate than any model could ever produce in the field. Our reports are done in white paper fashion, much like you saw with the UL report. And in this test, where we used a large national retailer in the United States market, we testing rooftop equipment, you'll see the similar types of results. When we get to the second page of the report, you're going to see an executive summary. Here, we had 2 units being measured, where one was actually tested with the nanotechnology pre and post, and a control unit was just measured, and we used the same sets of data. It's worth noting that they were right next to each other on the same roof, obviously exposed to the same conditions, where we saw no results in the control unit, but obviously saw significant results in the testing unit, and I'll cover those generally here. Certainly, if you've looked at our last 2 series of data, videos on those series, you'll see that we focus on the kilowatts per ton, and in this test, we had an 18.2% improvement in kilowatts per ton, and in energy efficiency ratio, we had a 21.9% improvement in that metric, highly significant. Those are going to start to look very similar when you look at all of our tests, and the reason is that our accuracy is very high, therefore the results always look very similar. As you get into the report, you can start to see graphical representation of the data, and you will come upon charts like this. Why this is significant is for a few reasons. Number one, notice the sampling rates. In this area, you're going to have in baseline samples, you're going to have 47,000 samples. And in post, using these same filter criteria, you're going to have almost 46,000 points. So we're talking about 90,000 points, or 500 to 1,000 points are normally the standard. The accuracy of the data is very high. It's also worth noting that we're taking a test at all these different degree ranges. So not only are we averaging all of this data to come up with the final results, we also have tests at each individual degree or ambient degree outside. So anytime samples were taken and they recorded 76 degrees outside, they get lumped into this category, and so on and so forth. That's very significant because in the laboratory, you typically test one range of temperature, and it can serve for the entire test. But in the field, that changes. So we want it to be more comprehensive with the data. If you get to the next pages, you're going to see the energy efficiency ratio portion and the coefficient of performance. These are 2 similar categories of measurement. They're basically different ways to look at the efficiency of the unit, and you will see the exact same trends. We're using the same data that was previously outlined in the kilowatts per ton section, and we are seeing an inverse of relationships here, where the kilowatts per ton dropped. Here the energy efficiency rises. So in baseline fashion, you have the baseline performance here, and in the post, certainly you see it rising. If we move over to the control unit, when we look at kilowatts per ton, you're going to see that there's no substantial differentiation, or basically no improvement. And in some cases where the post is in black, it even got a little bit worse. That's due to environmental conditions. So this is why it's really good to have a control unit in this case, because you can see that the untreated unit had no significant change. The last little piece I'll cover is the number of points that are being measured in the field. This is a very comprehensive list and is normally much more substantial than anything that's typically done in the field.
So after reviewing our UL lab data, our field data, and now our forensic data, which we're very excited about, you know that your systems have an efficiency issue and that we can overcome it. We look forward to working with you, and I hope to do that very soon. Thanks for watching our video series on data, and if you missed the first videos, please check the links to catch up on those too. Thank you.